Alright, this chapter CC7, we're going to look at the different types of bonding and the different properties. So you've got 4 different types of bonding: ionic, metallic, and then 2 types of covalent. You've got simple covalent, which is also called simple molecular, or you've got giant covalent. To be able to spot which type of bonding you've got, you'll use your periodic table to work out if you've got metals or non-metals. If you've got both, a metal and a non-metal, it's ionic. Just a metal by itself is metallic. If it's non-metals, it's going to be either simple covalent or giant covalent, and I'll show you the difference in a second. Alright? In order to work out if you've got a metal or a non-metal, you're just going to use your periodic table. This line here over to the right separates the metals, which are all on the left, from the non-metals, which are on the right. So if I've got something from the left, sodium, and something from the right, chlorine, I've got an ionic bond or an ionic compound. If I've just got something from the left, so just sodium by itself, that would be metallic. Alright, so if I give you my examples here, alright, so I've got sodium chloride, a metal and a non-metal, magnesium oxide, a metal and a non-metal. But when I've just got the metal with no non-metal, that's when I call it metallic instead of ionic. Now, if it's covalent, as I said, you've only got non-metals. So if I come back to my periodic table, you're dealing with elements that are over here if it's covalent. So you could have an oxygen bonded to an oxygen, that could be covalent, a carbon bonded to an oxygen, a hydrogen bonded to an oxygen. Hydrogen is a non-metal, so that would also be covalent. So I've got some examples here, alright. I've got H2O and CO2. But then for giant covalent, I've got things that aren't necessarily on my periodic table. I've got diamond, graphite, graphene, and carbon nanotubes. So they're all what we call allotropes of carbon. They're all made of carbon. Carbon is a non-metal, and these guys all have giant covalent structures. Now you will just have to learn these examples off, okay? Other example you've got is SiO2, which is silicon dioxide. So if you've got non-metals, and it's one of these examples, it's giant covalent. If you've got non-metals, and it's not one of these 5, it's going to be simple covalent. So everything that's got non-metals only, and is not one of these 5, is going to be simple covalent. And once you know what category it falls into, you can predict properties. So properties, we're typically talking about melting point and boiling point, alright? I've abbreviated it to MP and BP, but you can see they've all got high melting and boiling points apart from those that are simple covalent. And if you look at the examples, that should make sense. We know water is liquid at room temperature. Carbon dioxide is a gas, whereas your metals are solid, okay? Diamond is solid. So these guys have a lower melting and boiling point, but they're the only ones with a low melting and boiling point. So if you learn that the simple covalent have low melting and boiling point, you can just remember that every other category is high. The only ones that always conduct electricity are metals, alright? So metals always conduct. And again, if you think of the plug that you, on your charger, it's got metal prongs at the end, alright? So metals always conduct electricity. If it's covalent, it never conducts electricity, alright? So that's easy to remember. Okay, it's the ionic one that's a bit awkward. It does conduct electricity when it's liquid, okay, so if you've melted it, it conducts, and if it's aqueous, if you dissolve it in water, it conducts, but if it's a solid, it won't, okay, but it's only ionic that the state matters. Metals can be solids or liquids, they'll conduct electricity. These guys just never conduct, but then ionic won't conduct when solid, will when liquid, will when dissolved in water. Alright, there's a question on the next page. I want you to press pause, and I want you to have a go at filling in question 1, which is a table. Alright, so I filled in the top row for you, alright. I wanted you to fill in the next 3. We said the only one that has a low melting and boiling point are the simple covalent. So I can call it simple covalent or simple molecule. Covalent never conducts electricity, metallic though always conducts electricity. So that's what it means by properties. If I asked you for a property of a metal, you can give me one of these 2. The property of something giant covalent, you can give me one of these 2. Alright, the next thing we need to look at is we need to be able to explain these properties. So I've got this big flow chart written out, which I see probably looks a little bit intimidating, but I'm going to go through it with you, alright? There's not that much you have to learn. There's basically 4 answers you need to learn, and you can use those same answers for everything. All right, so is it solid? Is it strong? Is it a high melting point? Does it have a high boiling point? All right, if the answer is no to these questions, all right, so if it's a liquid or a gas, if it's weak, if it's got a low melting point, a low boiling point, and they ask you to explain why, your answer is always this. Okay, if the answer to this question is no, the reason is you've got a simple molecule. And if you've got a simple molecule, you've got weak intermolecular forces that don't require much energy to overcome. So for an example, I could say, why is carbon dioxide a gas? Okay, because I'm saying gas, so it's not a solid, this is the answer I give. I could say, why does water have a low melting point? Okay, so because it doesn't have a high melting point, so the answer is no, you're going to write this. I could say, why is something weak? Okay, so because it's not strong, this is going to be your answer. So if the answer to any of these questions is no, this is going to be your answer. So I do want you to make a note of this because you're going to use this answer in a second. Now, if the answer to these questions is yes, and it's solid or it's strong, it's got a high melting point, all right, then you're going to have to do a little bit more work, all right? You're going to have to ask yourself another question, okay? And that question is, does it contain a metal? All right. Now, if it does not contain a metal, all right, so if it's solid, strong, high melting point, high boiling point, but it doesn't contain a metal, that means it's joint covalent. And your explanation is lots of strong covalent bonds require lots of energy to overcome. So it will always be this answer. If it's solid, strong, blah, 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 but it doesn't contain a metal, this is always going to be your answer. If it does contain a metal, you've got one more question to ask, which is, does it contain a non-metal? If the answer is yes, all right, then that means it's ionic. And you're going to talk to me about this strong electrostatic force between oppositely charged ions. If the answer to that is no, then you're going to tell me that you've got a metal. And this here will be your answer. So if I literally just put a big box around these 4 answers, these are the only 4 answers that you need. They answer every question, even though the questions look different every time. These are the answers that you need. Okay, they're the 4 answers that you need. All right, so I'm going to show you how to use my flowchart. Okay, you're going to use it to answer the questions on the next page. All right, so if I turn over here, it says explain why NaCl has a high melting point. Come back to my flowchart. Is the melting point high? The answer is yes. So I come here. Does it contain a metal? I asked you about NaCl. Na is a metal, so the answer is yes. Does it contain a non-metal? Cl is a non-metal, so the answer is yes. Therefore, this is my answer. So the answer to number 2 is strong electrostatic forces between oppositely charged ions. So please write that as your answer for number 2. If we look at number 3, explain why graphite has a high melting point. Okay. Does it have a high melting point? Okay, I've told you it does, so the answer is yes. Does graphite contain a metal? Now, graphite, I told you, was joint covalent. That means it does not contain a metal, so the answer is no. And this is your answer to question 3. So you'll say joint covalent, lots of strong covalent bonds require lots of energy to overcome. So that will be your answer to question 3. So make sure you write that down for question 3. Question 4, CO2 is a gas at room temperature. Explain why. All right, so I'm telling you it's a gas, so is it solid? The answer is no, it's not solid because it's a gas. Well then, this is your answer. Why is CO2 a gas? Because it's a simple molecule. Weak intermolecular forces require little energy to overcome. Okay, so essentially there are only 4 answers. Okay, we've just seen 3 of them, and if you know these 4 answers and which one to pick, you'll always get all of your marks, and it's typically 3 marks. Okay, so this is the answer for number 4. Please write this down for number 4. Now, the next few questions are on electricity. Okay, Again, another little flowchart. This one's a little bit simpler, okay? Can it conduct electricity? If the answer is no, then your answer is it does not have mobile charge carriers, okay? That will always be your answer. So why does something not conduct electricity? You'll just say it does not have mobile charge carriers. If the answer is yes, and it can conduct electricity, then you've got another question to ask. Is it ionic? Now remember, we said ionic was a metal and a non-metal. If it is ionic, then your answer to can it conduct electricity is it has free moving ions. If it is not ionic, then your answer to can it conduct electricity is it has delocalized electrons. So again, I'll show you how to use my chart. Explain why copper conducts electricity. So copper does conduct. So can it conduct electricity? Yes. Is it ionic? Copper by itself is a metal. There's no non-metal. So the answer is no. And that means the answer to that question is delocalized electrons. Copper has delocalized electrons. That's why it conducts. So that would be the answer to question number 5. Explain why graphite conducts electricity. Can it conduct? Yes. Okay. Is it ionic? No. Graphite is not ionic. We said it's made of carbon and it's giant covalent. The answer is no. It means again that it must have delocalized electrons. Okay. Why does solid magnesium conduct electricity but solid magnesium carbonate cannot? Okay, so there's two parts of this question. Solid magnesium can conduct, solid magnesium carbonate cannot. So I'm going to look at solid magnesium first. Okay, it says it can. I need to explain why. So can it conduct electricity? Yes. Is it ionic? No. Solid magnesium is just a metal. There's no non-metal there. So the answer to the first part, solid magnesium conducts, because it's got delocalized electrons. The second part, it says solid magnesium carbonate. Okay, so it's not just magnesium anymore, it's magnesium carbonate. And in this example, I've got magnesium, which is a metal, and then carbonate, a non-metal. So this is an ionic compound. Okay, but it's saying solid magnesium cannot. Okay, so when I come over here, can it conduct? The answer is no. So actually it doesn't matter what it is. It doesn't matter that it's ionic. If the answer is no, I'm just going to write this. It does not have mobile charge carriers. Okay, solid magnesium carbonate does not have mobile charged carriers. And that's my answer. All right. Explain why molten sodium chloride can and solid sodium chloride cannot. All right, so the first one can conduct, and it's sodium chloride. So can it conduct electricity? Yes. Is it ionic? Sodium chloride, metal and non-metal, is ionic. So I'm going to say, all right, that the molten one has free moving ions. All right, the molten one has free moving ions. All right. The solid one, all right, it says it does not conduct electricity. Well, if the answer to that question is no, it does not have mobile charge carriers. Okay, and that's the same every single time. Does not have mobile charge, I'm not going to write it all out, but does not have mobile charge carriers. Okay, I know the flow chart is a bit of a pain to write out, but it essentially highlights that there's only 4 answers that you need for melting and boiling point and strength questions, and 3 little answers, very short answers, that you need for conducting electricity. And these 7 answers can be used for all of those exam questions. So it is worth writing these answers down and making sure you've got a copy of the flow chart. Last little question, what is a polymer? All right, I just said I put this one in, even though they haven't really asked it before. Polymers are just long chains made of monomers. They're long chains made of monomers, okay? And all a monomer is a small unit, and then you repeat the same thing over and over and over and over again. Okay, so you take a small molecule and then you just repeat it over and over and over and over again, joining all of them to make a really long chain. And that's what's meant by a polymer.